Today, another important chapter is carbonyl compounds and carboxylic acid. Look at that. We'll go as carbonyl compounds and carboxylic acid. Very important. These two topic is very important topic. In carbonyl compounds, we discuss about aldehydes and ketones. In aldehydes, ketones, aliphatic aldehyde and aromatic aldehyde, aliphatic ketone and aromatic ketone. And the same way, if you go for carboxylic acid also, aliphatic acid and aromatic acid, preparation and properties. And how we'll discuss some good question is there. Some good question we'll discuss in after the 40 minutes or 45 minutes. Listen. Now, I want to take, before going to take the preparation of, I'm going with very important. Preparation of aldehyde. I'm going with an aldehyde. What is the preparation I'm doing? Very important reaction is called Rosamund reduction. What is Rosamund reduction? Look at this. Rosamund reduction. In this, I'm going to take as, I'm taking as R C double bond O Cn. It's called acid chloride. In acid chloride, if I treat it, it's called Lindlar catalyst. Lindlar's catalyst, which I'm going to get as R C double bond O H. What is Lindlar catalyst? Palladium, barium sulfate, hydrogen, which is going to give us a aldehyde is the compound. And next is, I'm taking as R, I'm taking C triple bond N. What is this called? It's called Stephen's reduction. Alkyl cyanide, in presence of, I'm taking as SnCl2 HCl. And I'm going to get R, C double bond NH HCl. I'm doing hydrolysis, H3O plus. So bond is going to break. I'm going to get as R, C double bond O H as aldehyde. So how this reaction takes place, how I got this intermediate is called Jimenez intermediate in Stephen's reaction. How this reaction takes place. Look at this. When SnCl2 and hydrochloric acid, when I'm mixing in these two, what is going to form? Look at this. SnCl2 plus HCl. When I'm going to mix, what is going to form as SnCl4 plus H2 gas liberated. This H2 gas only is going to add, what is that? Add and C triple bond N becomes what? C double bond NH. When hydrolysis takes place, I am going to get is what? R C double bond OH. Because imine undergone hydrolysis, acidic hydrolysis produce carbonyl compounds such as acetaldehyde, I can say. Now first is, the reaction is called Rosamund reduction. The second reaction is Stephen's reaction. It's a reduction of Cn becomes what? CHO. Cn becomes CHO. How? SnCl to HCl. What is happening? SnCl for H2 gas. That H2 gas can reduce C triple bond and becomes CH double bond NH. Then hydrolysis of imine produce RCHO, and Lindlar catalyst acid chloride becomes aldehyde. The reaction is called Rosamund reduction. The next is very important reaction. The reaction, we can say the reduction process called Dibol H. What is Dibol H? Diisobutyl aluminum hydride. It reduces cyano compound into ester. It reduces cyano compounds into ester. It reduces ester into aldehyde. I'm repeating again. Dibol H. The Dibol H, it reduces cyano compounds into an aldehyde, ester into an aldehyde. Look at that. First, we'll go what is Dibol H structure. See, I told you isobutyl aluminum hydride. That means I'll take simple example. ANH3 is called aluminum hydride. Now, I'll write Dibol H. Diisobutyl aluminum hydride. How? Look at this. ANH. I'm introducing isobutyl group. This H is responsible for reduction. We have only H. So diball H can give only one H minus ion for reduction process. That's the reason diball H can reduce ester into an aldehyde and cyano compounds into an aldehyde. It's a special reagent, diball H. Look at the reaction. Listen. Now, I'm going with that. Take the example. R, C double bond O, CH3. I'm using is what? Diball H. I told you, what is this H? Diball H is what? Diisobutyl aluminum hydride. It can give only one H minus ion. Therefore, the H minus ion is coming from where? Diball H attacks here. Bond is going to break. Why it attacks here? Carbon, oxygen. Which is more electronegativity? Oxygen. Therefore, delta minus, delta plus attacks, bond breaks. And going to get is what? R. C double bond O H plus is what? CH3O minus. I got the product of is what? Aldehyde. Now, cyano compounds. I'm taking, look at this R, C triple bond N. I'm taking diball H. So, what is the role of diball H? It produces H minus ion. So, once the H minus ion, look at this, carbon, C triple bond N. I can write delta plus, this is delta minus. So, minus attacks here, bond breaks. Now, I'm going to get is R, C double bond N minus, and this is H. If I'm doing acidic hydrolysis, H3O plus, so imine type of bond is going to break like this. Here is O, here is what? H2. Now I can take it as what? As R, C double bond O, H. So that means what are all the important preparation of aldehyde? One is, we can say, Rosamund reduction, Stephen's reaction. Then by using diball H, in diball H, ester into an aldehyde, cyano compounds into an aldehyde. Because these are all the special reagents, diball H. Diball H cannot reduce carbon-carbon double bond and carbon-carbon triple bond. Please keep it in your mind. Diball H cannot reduce double bond as well as triple bond. Now, look at that. Now, another very important reaction, Gattermann-Ghost reaction. Look at this. Now, I'm taking benzene. I'm taking benzene in presence of what? CO, HCl, anhydrous AlCl3 using is what? Cu2, Cl2. CO, carbon monoxide, hydrochloric acid, anhydrous AlCl3. It's a catalyst of Cu2, Cl2 which produce this CHO. It's an example of EAS. EAS means what? Electrophilic aromatic substitution reaction. Look at that. I'm taking here C triple bond O. Here you have the lone pair. Plus I'm taking HCl plus AlCl3, which is going to produce as H attacks. I can write H bond C double bond O as plus. Its electrophile is formed in this reaction. Plus I can write as AnCl4 minus. Now this is electrophile. This is benzene ring. So electrophilic aromatic substitution reaction takes place. Now this can attack. Now you are going to get as the slow step. The slow step is what? Redetermining step. H, and here you have the H is there. Minus can attack this H plus. Again the bond formation. Second step is what? Fast. You are going to get as what? Benzaldehyde. That's all. So this is the example of Gattermann-Ghost reaction as a single step. Then means benzene is converting into benzaldehyde by using COHCl in presence of anhydrous AlCl3 and Cu2Cl2 getting as a benzaldehyde as the product. That's all. Yes. Now, next I want to explain that. Can I clean this? Listen. So this is the preparation of what we can say that aldehyde. Now we are going for preparation of ketones. In preparation of ketone, now I want to explain that Grignard reagent. and I'm taking as CH3 C triple bond N plus CH3 NGBr. I can say this is delta minus delta plus. Look at that. Carbon, nitrogen, which is more electronegativity. Carbon is less electronegativity than oxygen. I can write this as delta plus, delta minus. Attacks, bond breaks. So now I can write CH3, C double bond, N, NGBr, and here CH3. Now if I hydrolysis, H3O plus, so the bond is going to break. I can say here O, I'm going to get is what? CH3, C double bond O, CH3. I got ketone. If I'm taking what we can say benzyl cyanide, or I can say phenyl cyanide, I get acetophenone. Even another example, Friedel-Crafts acetylation is the preparation of ketone. Look at that. Look at that. I'm taking, listen, benzene, we have discussed already, benzene plus, I'm taking CH3, C double bond O, Cl, I can take as anhydrous AlCl3 is example of Friedel-Crafts acetylation, benzene, acid chloride gives what? Acetophenone. That's all. I can say it's a aromatic ketone. So, and another important, look at this, even, and I'm taking one more point, look at this, I'm taking as CH3, I'm going to use as 2 mole of, I'm going with as NBS. So NBS is N-bromosuccinamide. They may give always the free radical substitution takes place in allylic. This is allylic carbon. Sorry, it's a benzylic carbon. So what is going to happen? You may get it as CHBr. Here also is what? Br. Now I'm doing hydrolysis. H2O. Now what I'm going to get as CH, OH, and this is OH. This is called gem diol. Gem diol is highly unstable. So what will happen in the reaction mixture itself? The removal of water molecule H2O, which we are going to get it as aldehyde. This is another method of preparation of aldehyde. This is preparation of ketone. So we have learned as of now what we can say that preparation of ketones as well as aldehyde. In exam, how they will expect from you. We'll discuss one question now. Listen. Look at that. Now, I'm taking very simple one by one. I'm taking as Br. I'm taking cyclopropane. I'm taking bromocyclohexane. I have taken. In this, I'm going one by one. I'm using alcoholic KOH. Second will be I'm using NBS. It's easy to now we can have the better clarity. Now NBS and third will be I'm using as NG. Listen children, the question is, they are given, I can take this is 1, this is 2. I can say 1 bromo, 2 methyl cyclohexane. They are given, these are all the reagents. One is alcoholic KOH, NBS, Mg ether, CHCCN. Find out the major product. See, what is alcoholic KOH? It's an elimination reaction because it's secondary halide. What alcoholic KOH is going to produce as a base? Base is going to abstract the proton. This is beta. Alcoholic KOH always abstract the proton. Carbon having, what we can say, more hindered carbon. So the first step here is H is there. The base. So base is going to abstract the proton. Therefore, it leaves. So therefore, first step, what you are going to get as, you can say as here is CH3. Now, next will be, we have to go with that. I'll take one thing. Yeah. The next step is what? NBS, N-bromoxylamide. Now I can say here, this is allylic carbon. Therefore NBS, I can say that here is what? Br. Now Mg ether, what I am going to get as? Now we can make it as CH3 bond. I can make it as MgBr. And next will be CH3, what do we get? Cn. I can write as CH3 C triple bond N. So this is delta minus. Now this delta minus, can I attack this? The bond which is going to break. And hydrolysis, if I do, you may get the compound of this is what in the examination they will expect you. They will give the list of reagent. They may give the compound. They'll ask you to find the major product. This is what the real the trend of asking JEE means. And one more question. Look at this. This is 2015 JEE mains offline question they asked. Look at that. They're asking. They will take it as benzene. Let us take it as toluene. They take it as they take KMnO4, acidic medium. They gave A, then they gave us SOCl2 is B, then they gave us what? Palladium, barium, sulfate, H2C. Find out they, or we can say A, B, C respectively. Now, KMnO4 acidic medium, toluene, which is going to form us benzoic acid. When benzoic acid treated with SOCl2, acid react with SOCl2 gives acid chloride. Cl. Now we know what is the reaction is called Rosamund reduction. We are going to get the compound of. That's all. This is what you may expecting in the JEE mains question. You should know all the naming reactions. Rosamund reduction, Stefan's reaction, Gattermann-Gauss reaction. Now next we will go. Next is the properties of carbonyl compounds. So what is properties of carbonyl compounds? Look at this. Now I'm taking as, let us go with that. I'll take R. Let us take, I'll take it, easy to understand. CH3, C, double bond O, H. So carbonyl compounds undergone nucleophilic addition. Carbonyl compounds undergone nucleophilic addition. How? Look at this. This is the carbonyl carbon, I can say. I can say this is delta plus. This is what? Delta minus. It's a sp2 carbon. The bond angle is what? 120. Therefore, the incoming nucleophile may attack front as well as back side. Now I'm writing that nucleophile. Nu minus. So attacks. It may attack front as well as back because of the bond angle of the carbon is 120. So therefore, I can say that CH3, I say C, O minus and H, and is what Nu. Now observe that. What is happening? sp2 carbon becomes sp3 carbon. Therefore, that is a slow step. Then using as H3O plus, which I am going to get is what? CH3C, OH, H, Nu. This is fast. Therefore, the addition of nucleophile, a change in hybridization is the slow step. Now, the next question you may ask me in your mind, so whether aldehyde is more reactive towards nucleophilic addition or ketone is more reactive towards nucleophilic addition. Here there are two factors. One is electronic factor, another one is steric factor will play a major role which decides which undergo faster nucleophilic addition. Let us take the example, we'll discuss that. I'm taking very simple example. Listen, I'm taking as simple example HC double bond OH. I'm taking as CH3 C double bond OH. Then I'm taking is what CH3 C double bond O CH3. I am taking three. One is formaldehyde, acetaldehyde, and acetone. Tell me among these three, which will undergo the nucleophilic addition faster. So how to decide and how to look at this? Look at this. Now, this is delta plus, this is delta minus, delta plus and delta minus. This also is what? Delta plus and delta minus. Now here the steric factor, electronic factor decides the rate of reaction of nucleophilic addition. So now this what group I can say? It's a plus I group. I can say this also is what plus I group. Even I can say this also is what plus I group. When the plus I group is there, what is the role of plus I group? It gives electron. Once it gives electron, the charge on the carbon decreases. When charge decreases, obviously what we can say, the nucleophile cannot attack easily. But look at this, here H and H is the reference only. Therefore here the carbon has the more positive charge. When the carbon having the more positive charge, I can say that nucleophile can attack easily. But here what we can say, here will have the more charge. Here will be what we can say, somewhat less charge as compared to this one. This will have still less charge compared to these two. Therefore, can we say generally the ketones are less reactive than aliphatic aldehyde towards nucleophilic addition reaction. Reason is what? Because of steric hindrance, because there is a 2-methyl group which sterically hindered, therefore nucleophile cannot attack easily. Or we can say that there are two, what we can say, the plus A group which nullify the charge, therefore the less positive charge is there, therefore nucleophile is not able to attack easily. And what about in the case of, look at this, I'm taking as C double bond OH and I'm taking is what? CH3 C double bond OH. Now what we can say? It's an aromatic aldehyde. This is what the aliphatic aldehyde which will undergo nucleophilic addition faster. This I already told you that this is the order of reactivity of nucleophilic addition. Now, so how did you say aliphatic aldehyde is more reactive than aromatic aldehyde towards nucleophilic addition? Here what is happening? Phenyl ring, C double bond O both are same plane. They take part in the resonance which makes the more electron rich. Look at this. The carbonyl carbon become more electron rich, therefore the nucleophile cannot attack easily as compared to aliphatic aldehyde. So we can say that the nucleophilic addition faster in the case of aliphatic aldehyde as compared to aromatic aldehyde. The next question, sir, in aromatic aldehyde, if it is plus R and minus R group is attached, what is going to happen? That's all the logic. Look at this. Now, in that aromatic aldehyde itself, now I am taking as C double bond OH. Let us make it as NO2. Let us make it as C double bond OH. Let us make it as CH2 as CH3. Can you say, in among these three, can you arrange increasing order of nucleophilic addition? Now, what is the group is attached? NO2 group. It's a minus R group. Now, this is what CH3. It's a plus R group. Now, you please tell me, when plus R group, what is going to happen? It gives electron. Therefore, C double bond O has the positive charge, will be nullified. Therefore, charge is less. Therefore, attacking nucleophile will be very less. Because wherever the more positive charge, there is nucleophile attack. Now, look at this. This is what as a minus R group, which can pull the electron. Once they pull the electron, therefore, the positive charge on this carbonyl carbon is going to increase. Therefore, attack of nucleophile is faster. That means we can say generally, In aromatic benzaldehyde or aromatic aldehyde, if the plus R group is attached, addition of the nucleophilic addition is lower than benzaldehyde. If it is minus R group is attached, addition of the nucleophile faster than what we can say benzaldehyde. Therefore, the order is what? Can I discuss one question based on this? Look at that. Can you answer this question? This is what 2019, 2020 JEE mains question. Arrange increasing order of nucleophilic addition of the following molecule. This is what the question. Now these four I have given that. Can you please arrange the increasing order of nucleophilic addition of the following molecule? Aromatic aldehyde. Give the number. This is 1. This is 2. This is 3. And this is what? 4. Now please, can you tell me, sir, what is going to happen? Observe that. First, go with that whether plus R and minus R group is attached. Now I can say CHO with respect to para position, it is a plus R group. CHO with respect to para position, this also plus R group. I can say this is plus R. This also I can say is what? Plus R. But we can say that the OCH3 is stronger plus R than CH3 due to the resonance. This due to hyperconjugation. Therefore, the 3 is the least reactive. Then what we can say that fourth one. So order is what? 3. Then is what? 4. Now the question comes from, so 2 and 1. Look at this is OCH3. Now CHO with respect to OCH3 is what? Meta position. So meta position means we should consider only minus I or plus I effect only. What is this now? OCH3 acts as a minus I group. So because of minus I group, which can what? The pull the electron. Therefore, the charge on the carbon is going to be what we can say the more positive charge. Attack nucleophile faster. Therefore, so meta-methoxybenzaldehyde is more reactive than benzaldehyde. This is what the JEE mains expectation. Are you able to follow what I am trying to say now? So 1. This is what the real JEE mains question of 2020. Repeating again. There are 2 plus R, minus I. Why this act as a minus I? Because with respect to CHO, OCH is attached in the meta portion. Any substituents with respect to what? Or phenol or carboxylic acid or aldehyde attached in the meta position, we should consider plus I or minus I effect. So here OCH acts as a minus I. So charge on the what we can CHO is increases, nucleophile attack faster. Therefore, meta-methoxybenzaldehyde is more reactive than benzaldehyde. And para-methoxybenzaldehyde is reactive than benzaldehyde. This is the order of reactivity. Please. Fine. Next is chemical properties. Very important. Chemical properties will be very important. Cyanohydrin formation. Look at this. I'm taking CH3 as C double bond OH. I'm using as Cn minus. Observe carefully what will happen to Cn minus, or we can use KCN in aqueous medium. So now I can write this is the first step. Thanks. What is going to break? The first step is what? Slow step. Now I can take it as CH3 as C bond O minus and H, and here is Cn. Next step is what? H plus H2O. What are you going to get as CH3 C OH? Here is H and here is Cn. Please observe carefully here what you are going to observe here. Molecule is chiral. And why is chiral? Because we can say that 4 different groups is attached. So end up with racemic mixture. Why racemic mixture? Cn minus can attack front as well as back. Cn minus can attack front as well as backside carbon. Why? Because sp2 carbon. First step is slow step. Second step is fast formation of cyanohydrin. Now if you do hydrolysis in strong acidic medium, we can say H plus, or you can say H2O heating. Now the Cn becomes what? I can say CH3 C COOH and is what? H and OH. It is called lactic acid. You may get what we can say plus as well as minus lactic acid. You will get racemic mixture. right? So cyanohydrin formation from acetaldehyde, you may end up with what we can say the racemic mixture. It's called asymmetric synthesis. What is asymmetric synthesis? Which produce the chiral compound as a product. Now it's achiral. Achiral becomes what? Chiral. That is the important of cyanohydrin formation here. Why first step is slow? Because the addition of nucleophile. Therefore, sp2 carbon becomes sp3 carbon. Clear? This is one of the important reaction. Next, look at that. Now, next will be acetol and hemiacetal. Very important. Carbonyl compounds can be protected by acetal and hemiacetal because acetols are stable in basic medium but unstable in acidic medium. That's a very important application. Is they look at this. Now I'm taking normal carbonyl compound. I'm taking C double bond OH. Now when I'm going to use as acidic medium as CH3OH, that means the alcohol is going to be used to protect what we can say carbonyl compound. How? Look at this. I'm using acidic medium. Why I'm using acidic medium? To enhance the electrophilicity of the carbonyl carbon. pH must be 5 to 6. Why? The reason is what? When H plus attacks, here the more positive charge. Therefore, the alcohol can attack easily, which produce, look at this, CH3, COH, here is H, here is what? OCH3. This is called hemiacetal. Now, again, I'm going to add with H plus and I'm using CH3OH. Again, look at this, CH3, CH, OCH3, OCH3. This is called what we can say acetol. Acetal. Acetols are stable in basic medium, unstable in acidic medium. Very simple. How to observe? In the place of double bond O, two what we can say CH3, OCH3 is attached. That means carbon attached with oxygen. Two alkyl group means acetal. If that carbon, oxygen with here hydrogen, and oxygen with what we can say alkyl group, hydrogen alkyl group, hemiacetal. Both are alkyl group is called what we can say acetal. So what is the importance of this? Protection, deproduction. Look at the application of acetal as well as what we can say hemiacetal. Look at that. Now I'm taking. Look at this. I'm taking example application. I'm taking as what? C double bond O as C double bond OH. As I'm taking, I'm asking you to convert. This is what is given. Can you convert this? Yes, we can convert. So what we'll think about that? Sir, can I use sodium borohydrate? If you use sodium borohydrate, both can be reduced. So can I use lithium aluminum hydrate? Both can be reduced. Then what is the logic? You have to protect any one of the group. Now what I'm going to do, same logic, I'm going to use as CH3OH 2 mole in acidic medium. Now the question mark may come. Sir, here ketone also can protect. Yes, this is example of nucleophilic addition. This is aldehyde. This is ketone. Tell me which will undergo nucleophilic addition faster. Can we say aldehyde? Therefore, I'm using 2 more. This is only going to be protected first. Or I can use, okay, fine. So now what I'm going to get as double bond O. I'm using is what? C, OCH3. I'm going to use OCH3. Here is what? H. Now I can use NaBH4 because so acetols are stable in basic medium because sodium borohydrate is basic naturally because it's H minus donor. So obviously what H minus can attack we have discussed now. That means we discussed in the previous class. So sodium borohydrate can reduce carbonyl compound to an alcohol. That's all. Now it's become OH and you have that CH, OCH3. I can write as OCH3. Now I can deep protect this one by using mild acidic medium. So deep protection takes place, which I got this. This is called, this is what an examination they will ask. Acetol and what we can say acetol can be used for protection of carbonyl compounds. Once it is protected, we can convert many things. Even I can give one more example to understand. Look at this, that give the better clarity. Now look at this. at this. So can you, same example, just I am taking like this. Just I am taking. I want to convert like this. Sir, how to convert this? So you are converting into what? As this. Sorry. Convert as so how to convert this? Look at this. So can I use lithium aluminum hydrate? Yes, you can use, but both will be reduced. Can I use sodium borohydrate? This cannot reduce, this is only going to reduce. Then what I have to do? You have to protect. Look at this, I am using. It's called ethylene glycol. I am using OH. OH in medium is what? Acidic medium, which is protected. It's called cyclic acetol, double bond O, OCH3. Now I can use LAH. So what is LAH? Which can reduce ester into an aldehyde. Acetols are stable in basic medium. It never reduced by any of the reducing. They are highly inert towards reducing agents. Now OH. What I told you, when I'm going to use LAH, you have to break the bond like this. This C double bond O becomes what? CH2OH. Just break this. C double bond O become CH2OH. Then again deep reduction using is what? H3O plus mild acidic medium. That's all. Over. Over. This is what? This is what the real JEE mains question. You got understand. Now come to the point. Listen. Come to the point. Now, a very important thing I want to say. The carbonyl compounds react with ammonia derivatives. Especially we have to discuss about 2,4-DNP. What is 2,4-DNP? I can say this is. I can say that. Listen. NO2. NH2. This is called 2,4-DNP. When the carbonyl compounds react with 2,4-DNP, look at this. I'm taking. Let us take as I'm taking benzaldehyde as the example. C double bond OH plus I'm taking. Look at this. H2N NH. I can take it as a NO2. I can take it as a what? NO2. What is going to happen? Very simple. Acidic medium. Just why acidic medium? To enhance the electrophilicity of the carbonyl compound. It's called 2,4-DNP. So water molecule is removed, which produces yellow or we can say orange PPT. What is the structure of the molecule? Look at this. Then take CH double bond N bond. What we can say? NH NO2. This is NO2. That's all. This is what the reaction. So that means when 2,4-DNP react with carbonyl compounds, produce yellow or orange precipitate. And even what we can say, when, I want to clean this, look at this. Now, if it is carbonyl compounds, I can write R, C double bond OH, and react with hydrazine in presence of acidic medium. What is going to produce? Hydrazone. It's called hydrazone. Why acidic medium is must? To enhance the electrophilicity of the carbonyl carbon. Look at this. Even I can say R, C double bond O, H, react with H2N OH is called hydroxylamine. Acidic medium is called oxime. Oxime can show cis trans isomerism. H2 is removed, you are going to get R, CH double bond, N, OH is called oxime. Oxime. So this is what you have to know. When the ammonia react with, we can call it as amine, which is going to produce a what? Imine is going to produce. When aldehyde react with ammonia, produce imine. Imine can be reduced by sodium borohydride. It's very important. Look at this. Now, and I'm taking as R, C double bond OH. I'm taking as H2NH. It's called ammonia. Just remove a water molecule. Produce in an acidic medium. Why? Because to enhance electrophilicity of carbonyl carbon. Always you don't use very high acidic medium. Don't go pH 1, 2. pH should be what we can say 5, 6. Mild acidic medium to enhance electro. Otherwise, this acid-base reaction takes place. Reaction did not take place at all. So should be very careful. Use pH should be 5 to 6. I will be getting as R, CH double bond, NH is called imine. You know that imine we have discussed, right or not? In Stephen's reaction, imine intermediate. So the process reverses. That's the reason using acidic medium. Whatever the ammonia goes ammonium salt, getting as aldehyde or not. Therefore, process is reversible. Why they are using tin essential to HCl? Because obviously the process is reversible. This is a reversible process. So when I am using what we can say acidic medium, ammonia comes out. Ammonia keep on removing. Equilibrium go towards the backward direction, gets aldehyde. Are you able to follow? That's the reason Stephen's reaction, they're using SnCl to HCl. Now we can understand better way. Now look at that. Now in this I'm going to use as sodium borohydride, NaBH4. Now what we can say, sodium borohydride can reduce imine into amine. Even lithium aluminum hydride, LaH, I can say R. Imine into amine. They are good reducing agent. That means imine can reduced by sodium borohydride, and imine can reduced by lithium hydride. Give us a what? Amine. That's all. Next is using this. I want to discuss some question. In exam, they will ask you. Chances of asking. Look at this. How it is interlinked with that. How they are going to ask. I'll give one question, nice question, it is interlinked. Then you go for the naming reactions and distinguish between that. Listen. I'm taking, listen. Let us take, directly I'll go with that. Cumene, O2 in presence of HNU, H3O plus A, I am going with that major. Now I am going with that. CHCl3 NaOH. C major, D minor, and this I can write it as major. I'll take it as NaOH. CH2, Cl. I'll ask you to find out BC, BC. I can take it as a. So this is what the question. I can write options in they ask in the exam. We know that this is cumene. Any of them knows? When cumene in presence of oxygen in light, obviously cumene isoperoxide, H3O plus. What is going to form? A is phenol. Now, this is phenol. Now CHCl3 NaOH. So what is going to form? Example of a Riemann-Riemann reaction. Major and minor. So major is what? We can write as OH, CHO. Orthohydroxybenzaldehyde is major due to intramolecular hydrogen bonding. Now, minor is OH, CHO, para-hydroxybenzaldehyde is minor. And NaOH-CHCl2, what is the reaction? It's a Williamson ether synthesis. Now, so what is the base? Base is going to abstract the proton. So you'll be getting the compound of O. I can write CH2 phenyl ring, and I can write CH2. This is what? But question they will ask you based on the chemical test. How chemical test? I'm asking you the question. I can say C can react with neutral ferrichloride test. Yes, C react. Neutral FeCl3 produce violet color. Yes, it is right. Why? Because it's a phenolic OH is there. In phenolic OH, they react neutral ferrichloride. But this I can say as E. I can say E cannot react with neutral ferrichloride. Why? Because it's a ether. Ether cannot react with neutral ferrichloride. That means I can say E no reaction with FeCl3. So statement they will ask you. What they will ask you as a compound C produce violet color on treatment with neutral ferrichloride. Yes, statement is right. They may say the compound E produce violet color on FeCl3. It's an incorrect statement because it's a ether. Ether cannot react FeCl3, cannot form complex with FeCl3, but phenol can form a complex with FeCl3 as a violet color. Yes, fine. Now look at this. Now I can say D. D can form yellow precipitate with 2,4-DNP. Yes, I can say as D can form a yellow PPT. Yellow PPT with 2,4-DNP. Yes, this is correct statement. Why? Because it has CHO. So that means 2-hydroxybenzaldehyde can produce yellow precipitate, can produce violet color on treatment with neutral FeCl3. But even this can produce yellow precipitate because CHO is there, but does not react with neutral ferrichloride test. So this is what you may expect in the examination of JEE mains. See, you know this is preparation of phenol. You know this is Riemann event reaction. You know this is what Williamson ether synthesis. So organic chemistry generally they may ask mainly from the naming reactions. And you should know test distinguish between phenol and ether, test distinguish between phenol and carboxylic acid. So many things are there. This is one of the example. Now put the heading. You can go with that. Iodoform reaction and tolerance reagent and filling test. Very important. Look at this. Now I'm going with that. Very simple. Tolerance reagent. What is tolerance reagent? Ammonical silver nitrate solution. I'm writing that as, whether we can write as NH4OH, AgNO3, and is called R. We can write as Ag, NH3 twice plus. This is called tolerance reagent. R can write. That means aldehyde can reduce as tolerance reagent, but ketone never, because ketone tough to oxidize. Now I can write R C double bond O H. I'm writing R C double bond O. I can go with that CH3. Here you will get as R C double bond O, O minus plus Ag. It's called a Silver mirror test. I can say that aldehyde can reduce as tolerance. It's a redox reaction. Even please keep it in your mind. Alkynes terminal alkynes can react with tolerance but does not reduce, only form white precipitate. Please keep it in your mind. And here ketone, you cannot break CC bond, very tough to oxidize. Therefore, with Ag NH3 twice plus no reaction. That means here it could be R could be aryl or alkyl. That means both aliphatic as well as aromatic aldehyde can react with tolerance. Even hemiacetal can react tolerance. That's what glucose are reducing sugar, because hemiacetal form. Hemiacetals are reducing sugar. Hemiacetal react with tollens. What is hemiacetal? I can write R, I can write CH, I can write OH, I can write as OCH3. It is hemiacetal form. Or I can take it as a CH3, it's better. It's acetaldehyde form of hemiacetal form. So this can react, which produces R, C double bond O, O minus plus Ag. But acetal, no reaction. Because acetols are what we can say stable in basic medium. Acetal is not reacted with what we can say tollens. Ketones, never. Ketones won't react with ammonical silver nitrate solution. Even I can say as acetal can react. Acetal, no reaction. But hemiacetal, it reacts. Hemiacetal, it reduces tolerance. Acetols, no reaction. Next one. What about fillings? Look at this. Fillings. The case of filling, I'm going with that. Same R. I'll go with that. CH3, C double bond OH. For the spelling test, I can go with that CuSO4, base of NH4OH. I can go with that potassium tartarate, which forms as R, C double bond O minus plus Cu2O. Look at this, it's a cuprous oxide. Cu2O. Look at this, Cu2 plus becomes Cu plus. That means aliphatic aldehyde can reduce fillings. Aromatic does not. And it's a red precipitate. Even though Cu plus D10 configuration it is colored due to charge transfer spectra. Cu2O, it's a red color, red precipitate. Even though it's a Cu plus, it's a D10 configuration. Still it is colored due to charge transfer spectra. And in the case of, I can write as aromatic aldehyde, and I can go with that ketones, no reaction. But hemiacetal, yes, react fillings. Acetols, no reaction. Next is, please write down, very important this is. Now, I'm going with that iodoform reaction. Very important. Its iodoform is nothing but oxidation of ketone. Iodoform nothing but is what? Oxidation of ketone. Look at this, what is the condition for the iodoform reaction? If carbonyl compounds, very important. Carbonyl compounds undergone iodoform. Sir, can we say acid chloride? Can we say amide? No. Carbonyl compounds, C double bond O. Carbonyl compounds undergone iodoform reaction. That's very important. Look at this. Now I'm going with that. Listen. As CH3, C double bond O group should be present. If this group is there, the molecule undergone is what? Iodoform. This group should be there for iodoform test. That means I can write as even CH3, CHOH. If this group is present, the undergone is what? Iodoform reaction. In ethanol, in alcohol, ethanol is the only compound undergone iodoform reaction. In aldehyde, acetaldehyde is the only compound undergone iodoform reaction. We'll go with the what is iodoform reaction. Look at this. I'm going with that CH3, C double bond O, H. I'm using is what? NaOH, I2. I'll give you simple logic of this one. So what is that? We should find out. Yes, the group is present. So therefore, what? We know that NaOH and I'm going to use base. What is the role of base? Base is going to abstract the proton. First I will write that. What is the product? And write O minus and Na plus. Plus I can write CH3. This is called iodoform. Now, what is the role of base? Base is going to remove H plus from the molecule. I can say in carbonyl compound, the alpha carbon having hydrogen is more acidic nature. Why? By using base, look at this, I'm writing CH2H, I'm writing C double bond OH, and I'm using as a OH minus. So what is the role of base? The base is going to tag this H plus. Now CH2 minus, C double bond OH. Now this negative charge is stabilized by CHO group. Why? Because take part in the resonance. It's called the enolate ion. Now I am using basic medium, is going to abstract the proton. Now I can write again as what? I2. Now I can write as what? CH2I, C double bond OH. Now the minus A group is attached. Observe that in the place of what we can say one hydrogen, I introduced one iodine. Now remaining this side, these two hydrogen also acidic nature. Now I can use what we can say another 2 mode of iodine, which I am going to by using the again what we can say basic medium and I2. Now all hydrogen is replaced by is what iodine. All hydrogens are replaced by iodine. That's the reason I told you CH3 is the condition. Now look at this. When I'm going to use as OH minus, if bond is going to attack here. Now this is going to break, which forms as C minus I plus you are going to get H, C double bond O, OH. This is acid. This minus can take H plus from here. We can write it as CH I3 plus H, C double bond O minus. Please observe the logic here. That means iodoform reaction. This is there. So break the bond here. This becomes CH3. Remaining part is what carboxylic acid. Are able to follow? That's all. So you break this bond. This becomes CH3. Remaining part becomes what? Sodium salt or carboxylate. That's what is happening. Observe the mechanism. So 3 hydrogen. In the place of 3 hydrogen, you substitute what we can say iodine. That's also you got the carboxylic acid. I give one more example to understand better. Look at that. Listen. In exam, what they will ask you. I'll take one simple idea. Listen. You can have that. I'll give an idea for iodoform reaction. Look at this. I'm taking. What is this? I'm taking a cyclohexene. I'm taking. In cyclohexene, I'm adding is what? NBS. What is NBS? N-bromosuccinamide. So it is an allylic or benzylic substitution. This is called allylic carbon. So Br is substituted. I can say here is Br. Now I am using is what? Mg. So what I am going to get as MgBr. Now if I am going to use as CH3C triple bond N. Now I can say delta minus. At that date bond breaks. Followed by H3O plus. What I am going to get as that's all I written. My question: this molecule undergone iodoform reaction? Yes. Now I am going to use as NaOH I2. So I told you where the bond is going to break. This C double bond O CH3. You break this bond. This becomes what? CHI3 plus remaining will be what? That's all. This is how we may expect in the JEE mains examination. Look at this major product they will ask you. Now next is very important. Aldol condensation. This is what? Aldol condensation. So they may aldol condensation. I told you secondary alcohol also undergone iodoform reaction. Example we can say that. See, we can take it as CH3, CHOH. I can say that CH2, CH2, CH3. I can say this is 2-pentanol. I can take this will be is what? CH3, CH2, CHOH and what? CH2, CH3. This is 3-pentanol. What is the chemical test distinguished between these two? Very simple, go with the iodoform reaction. Yeah, because it has this group CHOH is there, is undergone iodoform. This want to go undergo iodoform reaction. That's all. This is what in examination, which of the following molecule can give iodoform, except they may ask you. So you should observe very carefully. In alcohol, in primary alcohol, ethanol is the only compound undergone iodoform reaction. In aldehyde, acetaldehyde is the only compound undergone iodoform reaction. Ketone, you have to see that. The group should be CH3CO group should be there. Fine. Now come to the point. Next will be very important. Aldol condensation. Very important. I'm going with that aldol. In aldol condensation, what is the condition of aldol condensation? In carbonyl compound, alpha carbon having hydrogen. We should use the basic medium. I'll give you a simple idea. Look at this. I'm taking CH3, C double bond O H. 2 moles we should use, but I'm going to use as NaOH. Heating is must. I'll write the mechanism. I'll give you a simple idea also. Now, what is the product I'm going to get is CH3, CH double bond, CH and what? C double bond OH. See, what is the mechanism of the reaction? I told you, in a carbonyl compound, alpha carbon having hydrogen is more acidic nature. I'm using base. Role of base is what? It's going to abstract the proton. Once abstract that, which forms as anion, very important, C double bond OH. So anion generated. The first step is going to slow step, because after anion, you are going to add nucleophilic addition. Look at this. Attacks, bond breaks. They are doing a new step, H3O plus. I am doing that. I am going to get as, look at this, CH3, C, OH, H, CH2, C double bond O, H. This is the product. Now I am going to give us heating. Heating means even this carbon is what? More acidic in nature, because CH was there. So because of heating, this bond comes here. This will go, which produce more conjugation. More conjugation means more stable. CH3, CH double bond, CH, C double bond OH. Because of conjugation, this is more stable. So got the product. This is the mechanism. So this is the slow step. Addition of nucleophile is the slow step, followed by H3O plus the fast step, then removal of water molecule. This is the mechanism. I'll give you a simple method. Look at this. Where anion generated and what we can say attacks there. Look at this, taking 2 molecules. Where the anion generated from that H2, other molecule from remove oxygen. H2 is removed. It's called aldol condensation. Condensation means what? Removal of water molecule. I'll give you the idea. Look at this. See, this is the mechanism. It's very important. Slow step. Addition of nucleophile and formation of vinyl ion is very important. Look at this. I'll tell you a hint. That hint you have to understand. Listen. I'm taking this. How I'm going to say. Anion generate, from that remove H2, from other molecule removal of oxygen. Look at that. I'm writing C double bond OH. I'm writing as CH. I'm writing H2. Other molecule C double bond OH. I'm writing CH3. Look at the logic. I told you, if anion generate here, other molecule. That's all. Now write it. You can write as C double bond OH, and write CH, CH double bond, CH, CH3. Got it? That's all the logic. That's all. See what you do? Anion generate from that H2, other molecule remove oxygen, join that, you may get the molecule. But one trick is there. They may ask in JEE mains. They asked on JEE mains question to discuss that. Look at that. Now, I want to clean this. Suppose if they ask, look at this. If they are asking like this, OH minus 18 major. So can you please find out the answer? Since this is also alpha hydrogen, this is also alpha hydrogen. Very, very important. First thing we should understand, which you will undergo, because nucleophilic addition, example of aldol condensation, that means slow step is what? Addition of nucleophile. Tell me that. This is acetaldehyde, this is acetophenol. Tell me in these two which will undergo nucleophilic addition faster? this is nucleophilic addition faster than this, that means the anion generate from here. Are you able to follow? Why? Here also anion generate, here also anion generate, but addition of nucleophile slow step for the aldol condensation. That means, can we say here the anion generate? Extremely sorry. Here the anion generate, you are right. Here anion generate. So that means here H2, here oxygen is removed. That's all. Or you can write, first I'll explain the easy way. Look at this. Now obviously CH2 minus, or we can say C double bond OH, or a plus, or we can say like this, we'll take it. This is one possibilities. Or I'll take this is another possibilities. C double bond O CH2 minus, they will call the stable inorate, plus CH3 C double bond OH. Tell me whether this will be easy to attack or this will be easy to, because this is hindrance is there. The definitely this is more easier than this. That's what I told you, that in these two, which will undergo nucleophilic addition faster. This is undergo nucleophilic addition faster. So from that remove what we can say oxygen, and here from what we can say H2. So where anion generate, from that remove what we can say H2. Where the addition takes place, remove what we can say oxygen and join. That is aldol condensation. Look at this. The product is very simple. You can write as just removal of, you may get as this is the product. That's all. This is aldol condensation. Oh, logic is over. Now next one, go with that intramolecular aldol. And intramolecular aldol means what? What is intramolecular? So within the carbonyl compound, in a molecule, if we have two carbonyl groups are there, when I'm using the base, they undergone what? Intramolecular aldol. Look at the example. I'll take, look at this, CH3, C double bond O, I'm taking CH2, 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 C double bond O, H. I'm taking like this. Right. Now, what is the question is, when I'm going to use here as a base, what I told you, anion generate here, even anion also generate here. Why? Because two carbonyl groups are there. But please understand, which undergo nucleophilic addition faster? This is only. That means you should remove from what we can say oxygen here. And here only anion going to generate. Why? Formation of 6-membered ring. Give the number. Look at this. 1, 2, 3, 4, 5, 6. Am I right? Now what I am going to do? C double bond O, as I am writing as CH2. I am writing CH2, 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 C double bond H. What else is removed? Now give the number. Look at this. 1, 2, 3, 4, 5, 6-membered ring is formed. Now 1, 2. So double bond O. Now 1 and 6. I'm giving 1, 2, 3, 4, 5, 6. 1 and 6 is double bond is formed. That's all. This is a large. Suppose if they are asking this is that, when they are asking about what do we can say corresponding carbonyl compounds, you break this where that means double bond is formed. Here make it as what CHO, here is what CH3 over. Or you add here O and here is what H2. You may get the answer. That's all the logic of that. Alright, but in the exam, what they're asking, we'll see that. In the exam, they'll be asking us. Like that is given. They are given as Br to H mu, They gave us alcoholic KOH. They given us O3, ZnH2O. Then fourth will be NaOH, heat. This is major. This is what the 2020 JEE mains question. That is what are all the involved here. Very simple this is. Logic wise, if I want to go. See, they are given. Obviously, what I am using, see, whenever the ozonolysis is followed by base, definitely the reaction is intramolecular aldol. So when I want to get this, I told you the logic. I told you the logic. You make it here as what we can say, make it as a O. That means wherever the CH, that means the carbon attached, there you make it as a H. Here you make it as a what we can say oxide. That means, look at this. I'll get you. It could be as C double bond O H as CH2, CH2, CH2. I'll make it as CH2, C double bond OH. Now if I remove that water molecule, I got this molecule. This is what that means. When this is the molecule means what could be that ozonolysis product? Look at this. Break that, I got this molecule. Now this I want to get the alcoholic KOH means what could be the compound could be as Br. Bromobenzene with alcoholic KOH, I get cyclohexene, ozonolysis, that means 1,6 hexane diol, then aldol condensation, I got the compound. Now again this, and I am going with that as, this would be cyclohexane. That's all. Cyclohexane, Br light, bromo cyclohexane, alcoholic KOH, cyclohexene, ozonolysis product, I got it because bond is going to break, CHO, CHO, I got it. Then NaOH, intramolecular aldol. That's all. This is what the real JEE mains question was expecting from you. Put it down, it's very important. Now, next is Cannizzaro reaction. Next is Cannizzaro. Very simple. In Cannizzaro, no alpha hydrogen. No alpha hydrogen. It's example of disproportionation reaction. It's example of redox reaction. Look at this. I'm taking as H, C double bond OH, plus I'm taking H, C double bond OH in presence of NaOH. Just heating is must. You are going to get as H, C double bond O, O minus Na plus, as you can say as CH3OH. Fine. Here the slow step is not addition of nucleophile. Here slow step is what? Hydrate transfer. Because they are finding out experimentally. Because order of reaction can be find out experimentally. So here in Cannizzaro reaction, the slow step is what? Transfer of hydrogen. Hydrate transfer. Look at the mechanism. I'm taking as H, C double bond OH, OH minus, attacks there. I can write as H, C bond O minus, OH, here is H, another molecule, O minus bond C. I can take H, here is what? OH, bond H, plus H, C double bond OH. Look at that. Minus comes, this minus can attack here. This is called hydrate transfer. This is called hydrate transfer. The hydrate transfer is slow step. So what are you going to get as? That means H, C double bond O, OH plus CH3 O minus. Now this is acid, this is base. Therefore the proton transfer takes place between this. Which I'm going to get as that's all. This is the product of the reaction. So fine. For an exam, what they will ask you. Suppose in the place, this is the mechanism, this is the slow step, hydrate transfer slow step. Suppose in exam, what they will ask you. Look at that. Listen. One will be this is benzaldehyde plus formaldehyde. I'm taking benzaldehyde and formaldehyde. So what is the candidate reaction product? Next will be I'm taking as next will be I'm taking CHO methyl and take CHO and O2. What is going to happen? Look, this also I am writing as very simple. The first step I have in mechanism, addition of OH minus. So which is going to add OH minus? That group only going to transfer the hydride. That means which is going to transfer the hydride or which is undergone nucleophilic addition first, that become always acid. The other molecule is reduced. You tell me this is benzaldehyde, this is formaldehyde. Tell me which will undergo nucleophilic addition faster? HCHO. Therefore, the first step, the OH minus attacks here. Therefore, hydrate transfer takes place from this molecule to this molecule. Therefore, this is oxidized, this is reduced. So, whenever that they are going to use the formaldehyde as the one of the reactant in cancer reaction, you are going to get always sodium formate. That means formaldehyde get oxidized, other reactant get reduced. Now, why? Because this undergone nucleophilic addition faster. So, which is the hydrate transfer takes place. So, which is going to give hydrate transfer, that is get oxidized. Therefore, this get oxidized as HC double bond O, O minus Na plus I can take this is get as, this is very interesting. Now tell me this is, I told you this is para-nitrobenzaldehyde, para-methyl benzaldehyde. Tell me which will undergo nucleophilic addition faster. This, that's the reason. In benzaldehyde, the minus R group is present. They faster, what we can say, hydrate transfer takes place. So therefore, this is NO2. Therefore, this under nucleophilic addition faster. Therefore, this only going to transfer hydrate from this molecule. So therefore, this is oxidized. This is reduced. Product is. So, these are all the questions you may expect for the JEE mains. Fine. Now I want to clean this. Next will be go with that carboxylic acid. Very important of carboxylic acid. This is the preparation of carboxylic acid. What is the preparation of carboxylic acid? In preparation of carboxylic acid, we are going with, look at this CH3MgBr. I'm going with that C double bond O. Here what double bond O? This is delta minus, this is delta plus. Attacks there. Bond is going to break. What I'm going to get as CH3. C bond what? O minus. Double bond O. MgBr. Hydrolysis. H3O plus. What I'm going to get as CH3. C double bond O. OH. Called acetic acid. That means Grignard reagent react with carbon dioxide, produce carboxylic acid. It's a very important method of preparation. Then if we go with that, anything, if I'm going to take as, look at this, benzene, whatever the long chain of what we can say hydrocarbon if I'm having, in presence of what KMNO4, acidic medium, heating must, which I'm end up with what we can say as iodoform reaction is an example of what we can say preparation of carboxylic acid. Now, next, hydrolysis of, very important, hydrolysis of alkyl cyanide. Look at this. R, C triple bond N. In presence of a making is what? H3O plus acidic medium. And we're getting as R, C double bond O, NH2 is called amide. Called is what? Amide. Now this amide further hydrolysis, which I'm going to get is R C double bond O, which is called carbon. That means the cyano compounds undergone hydrolysis in both acidic as well as basic medium. How this listen. Now, how this mechanism is taking place? Now, I'm taking as R C triple bond N in presence of acidic medium. Look at this. This is a lone pair is there. Attacks. Beginning is what R C double bond. Then H. Here is what the positive charge is going to come. Now again the water molecule is there. When that H2 attacks, and beginning is what R C OH. Double bond is what NH. Now this bond goes, catamerism takes place, which I am going to get is what R C double bond O NH2. I got in partial hydrolysis gives amide. If complete hydrolysis, I am going to get carboxylic acid. That means what I am trying to say, when preparation of carboxylic acid from cyano compounds, when that RCN react with hydrolysis in presence of acidic medium or basic medium, end up with what we can say carboxylic acid. So don't forget about it. Next will be, I can go with that. The next, same thing. CN in presence of what we can say as basic medium, H minus, heat will be getting as R, C double bond O minus and Na plus what we can say as ammonia gas. This is the preparation of what we can say that carboxylic acid. Now Grignard reagent, then hydrolysis of cyano compounds gives carboxylic acid. Partial hydrolysis gives amide. Fine. Now come to the class. Next one. Now properties of carboxylic acid. First we are going with as R C double bond O OH. And I'm going to use as SOCl2. So what is going to happen? I'm going to get R as C double bond O Cl forms as acid chloride. When notice when it takes place, that means OH in the place of OH, Cl is going to be replaced. Fine. When I'm taking as R C double bond O OH is there. Again, form of what we can say that P4O10 heating. What is going to form? R C double bond O O, C double bond O, R is called anhydride is going to form. Another important point, the beta keto acid undergo faster decarboxylation. Look at this, I'm writing CH3, C double bond O, and write that CH2, C double bond O, OH. Now here I'm going to heat it. When I heat this, decarboxylation takes place. Why? Because this is alpha, this is beta. I can say that beta keto acids undergo faster decarboxylation. Why I tell you that? I'm going to get is what? CH3, C double bond O, CH3. Why this undergo faster decarboxylation? Because this is how the bond is going to break. It generates anion. Look at this, C double bond O and CH2 minus. Now what is happening? This anion stabilizes this. Anion stabilized by this minus R group, therefore reaction is going faster. That means beta keto acids undergo faster decarboxylation. Fine. Next, very important reaction, we can go with that, is that even when this acid chloride is there, look at this, I am taking C double bond O, Cl, acid chloride, which I am going to use is what? NH3, lone pair is there. This lone pair can attack. I am using base of what? Pyridine. Why I am using pyridine? I will tell you that. So what is going to form? R, C, double bond O, NH2 is called amide. Now, using what? HCl, what? The HCl is side product, pyridine is what? Base. Acid-base reaction takes place. You are keep on doing what? HCl, equilibrium go towards the forward direction. From acid chloride, you can prepare amide or not? Yes or no? Now this amide, when I am going to use as LaH, lithium aluminum hydride, it reduces, which produce what if you can say R. I can say that CH2 NH2. Amide can be reduced by what we can say lithium aluminum hydride, because C double bond O becomes what? CH2 and NH2. Now look at the next will be now the very important is called HVZ reaction, Hell-Volcard-Zelensky reaction. I am writing that as HVZ, Hell-Volcard-Zelensky reaction. Now, what is the condition? Could be that alpha, the acetic acid, carboxylic acid should have the alpha carbon having what? Hydrogen. I can write as P4 with what we can say X2 heating. We will be getting as CH2X, C double bond O, OH. It's called Hell-Volcard-Zelensky reaction. So next is, look at that. They are taking as, it's called orthoxylene using KMnO4. Using what? KMnO4, which I am going to get it as C double bond O, OH, COOH. It's called thallic acid. And thallic acid I am using is 2 moles of ammonia. What is going to produce as C double bond O, C double bond O, NH2. NH2 is called thalamide. Again, strong heating, which we are going to get as NH double bond O, double bond is called thalamide. Thalamide. Thalamide is what? Thalamide is strongly acidic nature. Why? This proton is not highly acidic in nature. And very important that the benzoic acid, please keep it in your mind. The benzoic acid, COOH group is the minus R group. COOH group is what? The minus R group. So if you introduce the electrophile only in the meta position, look at that. Now, let's listen. Now I am going with that. Benzoic acid. I am taking using as HNO3, H2SO4, so minus R, as I'm getting a COH and what PO2. That's all. This is what that carboxylic acid. Fine. Can we discuss some good questions? Look at some 3-4 questions I want to discuss with you. Listen carefully. Now, I'm taking very simple example from what I discussed. Overall, I'm going to take it. Listen carefully. Now I'm going with that. Yeah. You are going to answer the question. Benzene. I'm going with NaOH, high temperature, pressure, followed by H3O plus. Second will be CHCl3, NaOH. Third will be KCN. And fourth will be, that's all. Find out the major product. This is what they will find the major. I asked you major. Now what I have taken? Benzene. We know that NaOH, high temperature, high pressure. What is going to follow? It's an example of what we can say Dow's process. In Dow's process, what are you going to get as O minus Na plus. Because of hydrolysis, what are you going to get as phenol? Now I used CHCl3 NaOH. So what is the reaction is called? We can say Riemann-Riemann reaction. I asked major, therefore C double bond OH. Now what I given? KCN is an example of Cyanohydrin formation. OH, C. I can say that Cn, H, OH. It's a chiral compound. Able to follow what I am trying to say? So next, look at that. Next question. Can you try? Listen, I'm taking H. H. Find the product major. Next will be major product. Right. So these two questions just I want to discuss with you. So how's that? Look at this dibol H. This is carboxylic acid. So don't afraid when looking at the structure. Dibol H. What is the role of dibol H? It produces H minus ion. Once produce H minus ion, this is ester. Ester becomes what? Aldehyde. So look at this H minus. Attack here. Bond breaks. That's all. So definitely carboxylic acid is retained over. Now you are going to get as, right, as S. I can write O, OH. Now I can make it as C double bond H. That's our answer. This is a JEE mains question. Now this will be very interesting. Look at that, NaOH. What is the reaction? It's iodoform reaction. In the iodoform reaction, what I am going to do, obviously this is CH3. So what is going to happen? Bond is going to break. When the bond is going to break and I given H3O plus E, that means I am going to get as double bond O. I can say C double bond O, O minus and Na plus. Here is what CH3. Now plus is what CHI3. That's iodoform, I got it. Fine. Now what I given H3O plus means what? Salt becomes what as acid. Now okay, fine. Now what I am going to get as salt become acid. CH3. Now what I mentioned here, heating I have mentioned. Heating means what? Obviously beta acid undergo faster decarboxylation. I can say this is alpha, this is beta. So this is what JEE means. They will ask you. So think about that. Now look at that next one. Look at this next one. I'm taking. NH double bond O. You know that it's called a calamide. I'm using. This can answer. This is 1. I'm using is OH minus. I'm using the second will be as CH2Br and I. Find the major product. Find the major product. So what is the role of base? The base is always abstract the acidic proton. So now this base is going to, yes, now minus. Now this acts as a nucleophile. So obviously nucleophile going to substitute. This is called, this is what aryl, this is what alkyl. We know that aryl compound never undergone nucleophilic substitution unless until ortho and para position minus a group should be there. Nothing is there. Obviously this is alkyl carbon, sp3 carbon, therefore attacks bond breaks. So what is the answer? We are getting as N as that's all. This is a logic. Now next look at this. Oh, I want to clean this. Now, in exam what they'll do. So let me say this will be excess. This is 1. 2 will be is what? ABC. What is the answer of this one? See now HCHO HCl is nothing but example of electrophilic aromatic substitution reaction. How? That is H C double bond OH plus HCl. So now it is going to enhance the electrophilicity of carbonyl carbon. So you will be getting as H plus benzene ring attacks. You will be getting is what? OH after attains aromaticity. Now anyway excess of HCl, this is benzyl alcohol. This is benzyl chloride, you got it. Now they get AgCN. So AgCN, that means is going to act as a ampidine nucleophile. In that nitrogen is act as a nucleophile. Attacks, bond breaks, you may get it as NC. Look at this. This is what JEE mains expectation. So you should not afraid of HCHO, HCl. Think about that HCHO, HCl. Okay, HCl using for enhanced acidic medium. Yes, sorry. The acidic medium enhance electrophilicity of carbonyl carbon forms CH2OH. So excess is there. Forms a what? Now look at this. Now I'm going with that. OH. OH. Now we are going with SOCl2. Very interesting. Sir, SOCl2, this is phenol. You cannot break what we can say O bond H because of resonance. But this bond you can break it easily. They won't react, you are going to get as OH Cl. Now another look at this. Now I am using S. I'll go with that as okay. NaOH. So what is the role of NaOH? Base. Either this is acidic proton or this is acidic proton. So this is acidic proton and followed by is what? CH3I. So we are going to get as. Now we can go with that O minus and followed by is OH. Now you are going to get as next up CH3I. Attacks, bond breaks. This is what you may expect in JEE mains because you should know base. This is more acidic than this because it's a phenol. Phenolic OH is more acidic than what? Aliphatic alcohol OH. This is what the JEE mains expectation. This is what JEE mains expectation. Another point, look at this. Now, whenever is now. We are making like this, and just I made one question. This I am adding Mg CO2. What are you going to get? MgBr, you'll be getting the compound of as CH2, C double bond O, OH, and this is what NH2. Now if I am going to heat it very strongly, strong heating, this is acid and carboxyl molar water molecule. That means I can write it as ring formation. This I can write CH2 C double bond O H. This is one that ring formation takes place. Now here I can do nitration also. If I am doing as what you can say as simple reaction, I can write Br to Fe. So what is going to happen? Look at this. In this, I can say this is lone pair. Can what we can say activate the benzene ring. This can be activated by only hyperconjugation. Therefore, this is more predominant than this. Therefore, ortho, meta, para. So major is what? Ortho, meta, para. This is the answer. Look at this. These type of questions you may expect for JEE mains. Now next one. So another important thing in the case of we are going with as amines. These amines, I want to say that especially preparation of amines. We'll go with Gabriel thalamide synthesis. Now when I am going to go with that as NH thalamide using base as OH minus. I can say C double bond O, C double bond O has N minus. Now the Gabriel Thallamide synthesis is example of preparation of aliphatic amines. Aromatic amine you cannot able to prepare. Now I am going with that as I am taking CH3I because it follows SN2 mechanism. Therefore, the secondary and tertiary amine is tough to prepare from Gabriel Thallamide synthesis. We have to use only the alkyl halide undergone primary halides undergone SN2 reaction faster. So for Gabriel Thallamide synthesis, you have to use only primary halide. Secondary and tertiary halide tough to prepare because when the bulky substituents, the nucleophile cannot attack. Suppose if I am taking as CH3, CHI, CH3, secondary halide, no reaction. Reaction go very, very slow. But this will be fast. Attacks, bond breaks. NCH3. I'm doing hydrolysis. I can do H minus H2. Bond is going to break here H2. Here OH is going to come. We are getting as the answer of. It's a very important reaction. Gabriel Thallamide synthesis is only for primary aliphatic amine. Aromatic amine cannot be prepared from Gabriel Thallamide. Why? Aromatic amines I should use aryl halide. Aryl halides never undergone nucleophilic substitution reaction. Next one. Now, you can go with that. Amides are reduced by, I can use CH3, C double bond O, NH2. Amides, and I am using as Li, Al, H4. Amide can be reduced what we can say as CH3, CH2, NH2. Here, please don't ask me, sir, is undergone haloform reaction or no. Carbonyl compounds undergone only haloform. This is amide. Please understand. And next will be, I can go with that. Now even I can say CH3, I can use CH2CN, and I'm going to use as LAH. What I'm going to get as CH3, CH2, CH2, NH2. Now the LAH can reduce C and become CH2 NH2. Even LAH can reduce C double bond O into what? CH2 NH2. So don't ask me here. Can we go for the reaction is called Clemmensen and Wolff-Kishner reduction. Please understand. Listen. Now, another important point I can say from here. So, amide is reduced by lithium aluminum hydride. Same thing, CN also going to get what we can say as a primary amine. And next is, when I'm going to take it as, look at this. NO2, I can use as thin HCl, which you are going to get as. The next important reaction is Hofmann bromide degradation. When Hofmann bromide degradation, amide is converting into primary amine. Observe that. I'm using that. I'm using R, C double bond O, NH2 in presence of is what? Br2, AOH. So in this reaction, they will use that 4 moles of this and 1 mole of what we can say Br2. What you are going to get is RNH2. So in this reaction, there is an intermediate is called alkyl isocyanate. Look at the mechanism. Base, abstract the proton, RC double bond O, NH minus, Br2 reacts. We are going to get RC double bond O, NH, Br. Using again base. Base is going to react RC double bond O, N minus Br. Now this migration is taking place. So what is going to produce here? We can say that alkyl isocyanate is produced, which is the intermediate is formed. I can say as we will be getting as R N double bond C double bond O. I can say it is alkyl isocyanate. So it's forming here. So now if we do hydrolysis, we may get it as bond is going to break. We'll be getting as R and H2. So in this reaction, you can say the 4 moles of potassium hydroxide. That means here is 1, then 2. You may get further 2 more mole. You will use that, but now just keep it in your mind. So we can say 1 mole of Br2 and 4 moles of what we can say the base used for the Hoffman bromide reaction. Observe that 1 carbon atoms reduced in Hoffman bromide. But in the exam, what they will ask you, look at that. This is what I want. Listen. See, I am taking an exam. Listen carefully. I am taking. I will take simple example. C over H. I will take it the SOCl2. We know that SOCl2, I can say this is A. I am taking with this NH3, B with, I can go with that Br2, KOH. Now I can go with the B with LAH. Now I can say this is C, this is what D. Now they will ask you, can you arrange increasing order of basic nature of BCA? That's what they will ask you. I can say benzoic acid. I can say this is benzoyl chloride, COCl. Ammonia react, that means acid chloride, ammonia, what is going to form? Amide. This is amide. The amide react to, this is called the Hoffman bromide reaction. You may get us here aniline and BLAH, lithium aluminum hydride, reduces what I am going to get as so I can say amide, aromatic amine is benzylamine, aliphatic amine is the more basic, therefore order of basic nature, increasing order means B is weak base, then C, then what we can say, I can keep it as a B. This is what you may expect in the JEE means examination. They may give like this. Email you can take, I can go with, I can make it as one reaction as, I can look at this NaNO2, I can make it. So what is going to form? Diazonium salts. So from diazonium salts, I can do a number of reactions. That's all. This is what you may expect in the JEE mains examination. So do it very carefully, children. So next topic I want to discuss with properties of amine, then biomolecules. Then we'll discuss next class. That means complete organic chemistry is over. That means we'll discuss good questions in next class. Study well and be confident. And we have completed up to what we can say preparation of amines we have completed. So that means the 90% of organic chemistry is over. So when 90% of organic chemistry is over, practice the problem. Read the what we can say NCERT book thoroughly, go through the lecture again and again and practice well. And solve the last 2-3 years of questions. You may get more and more confident because Tuesday, Wednesday, Thursday you have the exam. So because of your understanding, what we can say, the organic chemistry well, so definitely you may perform well in the March exam. I have the confidence on you. I have full confidence on you. Prepare well, give your effort 100%. Never ever give up. First உங்களால் முடியும் நம்புங்க, கான்ஃபிடென்ட்டா இருங்க, கண்டிப்பா நீங்க பண்ணுவீங்க. So I have faith on you. I have the confidence on you. Hard work gives success. This is what I always believe. I always tell to my students. So you are my students. Definitely will perform well. And go through our lecture properly and solve last 2 years of problem of organic chemistry and go and write the exam. Definitely you will perform better than February exam. I have the confidence on you. All the best, children, and do well And thank you so much. We'll meet again. Thank you.